Number 12 THHN can be used because it is rated for 25 amps in the 75-degree column. This exceeds the 20 amps required by the nameplate rating and the car wash vacuum. The correct breaker size is the smallest breaker that is not less than the current indicated on the nameplate. In this case, the nameplate rating is 20 amps, so the correct breaker size is 20 amps. Using a larger breaker, such as a 25 or 30 amp breaker, would provide insufficient protection for the circuit. It is important to use the correct breaker size to protect the wiring and equipment from overcurrent. Overcurrent can cause the wiring to overheat and potentially start a fire. The National Electrical Code, or NEC, provides guidelines for selecting the correct wire and breaker sizes for different applications. Understanding these guidelines is crucial for ensuring electrical safety. The ampacity of a conductor, such as number 12 THHN, is the maximum current it can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on several factors, including the type of insulation, the size of the conductor, and the ambient temperature. The NEC provides tables that list the ampacities of different types of conductors in different conditions. When selecting a conductor for an application, it is important to choose one that has an ampacity that is equal to or greater than the load it will be carrying. It is equally important to consider the termination temperature rating of the equipment. This is the maximum temperature that the equipment's terminals are designed to withstand. The NEC requires that conductors be sized so that their ampacity, the termination temperature rating, is sufficient to carry the load. In this case, the terminations are rated for 75 degrees Celsius. Number 12 THHN is rated for 25 amps at 75 degrees Celsius, which is sufficient for the 20 amp load. The breaker size must also be appropriate for the application. The breaker is designed to protect the wiring and equipment from overcurrent. It does this by tripping or interrupting the circuit when the current exceeds a certain level. The breaker size should be selected so that it is large enough to carry the normal load current, but not so large that it will not trip in the event of an overcurrent. The NEC provides guidelines for selecting the correct breaker size for different applications. In general, the breaker size should not exceed the ampacity of the conductor it is protecting. In this case, number 12 THHN is rated for 25 amps, so the breaker size should not exceed 25 amps. However, the breaker size should also not be less than the load current. In this case, the load current is 20 amps, so the breaker size should not be less than 20 amps. Therefore, the correct breaker size for this application is 20 amps. Using a larger breaker would not provide adequate protection for the circuit. For example, if a 30 amp breaker were used, the wiring could overheat and potentially start a fire before the breaker tripped. It is important to note that these are general guidelines and that the specific requirements for a particular application may vary depending on the local electrical code. It is always best to consult with a qualified electrician to ensure that the electrical system is installed correctly and safely. In summary, number 12 THHN is suitable for this application because it is rated for 25 amps in the 75 degrees Celsius column, which exceeds the 20 amps required by the nameplate rating. The correct breaker size is 20 amps because it is the smallest breaker that is not less than the current indicated on the nameplate. Using a larger breaker would provide insufficient protection for the circuit. Always consult with a qualified electrician to ensure that the electrical system is installed correctly and safely and that it meets all applicable codes and regulations. Always ensure that all electrical work is performed by qualified and licensed professionals who are familiar with local codes and regulations. Electricity can be dangerous, and improper installation or maintenance can lead to serious injury or death. Furthermore, regular inspections of electrical systems are important to identify potential hazards and ensure continued safe operation. Be aware of the signs of electrical problems such as flickering lights, trip breakers, or unusual odors, and address them promptly. Remember, safety should always be the top priority when working with electricity.